Hello and welcome to today's Teardown sessions from CrowdSupply. I am your host, Helen Leigh, and I'm really excited to share that we're going to be nerding out with Anne Barela from Adafruit all about CircuitPython today. So I'll bring her on shortly, but before I do, rules. As always, we have got a lunchbox full of mystery hardware to give away to a viewer of the stream. All you have to do to win this box of mystery hardware is comment and question, keep us company. And if your comment or question is closest to the timestamp that I have written down on my notebook, you will win this device. You'll win this box of hardware. All very exciting. So that's for that. So please do, not just for the mystery hardware, but please do keep your comments and questions coming. It does make us feel a bit less like we're yelling into the void. So please do keep us company and let us know that you're there and say hi. Before I bring Anne on, I just wanted to share what's going on at CrowdSupply as well. So let's bring in, oh, I've not got them in there. Here we go. Let's have a look here. So let me just bring this in here. Add to the stream. Here we go. That's better. Too many computers going on. As you can tell, I've upgraded my studio space and I've got 2 computers and several cameras. So excuse me if I'm a little slow to navigate around this session. So I wanted to take you through a few of the pre-launch projects that we've got coming up that I'm really excited about. So these are projects that are getting ready to launch their campaign. So if any of these tickle your fancy, go and click onto their page and you can sign up for updates. We've got some of my favorites here are Bean Counter by Nick Poole, which is a wonderful little device for counting cut reel SMD parts. Really useful little thing. Can't wait to have that on my workbench. We've got a lovely little power supply for your breadboard called AntBBPS. Check that out. Also, one of my faves is the SHA RP Keyboard, which is a lovely little Linux computer in my favorite color of circuit board, purple. Also coming up, I'm really excited, SocoRad32 is a hackable open source ESP32 walkie-talkie. Who doesn't want one of those? I'm just sad I can't have one of them for Hacker Festival season, which is coming up. And another one that everybody's really excited about is the Lime SDR Mini 2.0. That one's going to go back gangbusters as soon as it comes out of the gate. So lots and lots of other things coming up here. So do have a little scroll through and see if there's anything that tickles your fancy and sign up for more information on those. I also wanted to give a brief shout out to our sponsors today, which is Xilinx, or AMD, as they're going to be known very shortly. And we do have a supplier launch program with them. So if you are thinking about developing something with an FPGA for a CrowdSupply campaign, please consider Xilinx. And if you get through to this program, we give you money off, we give you extra marketing support, all sorts of lovely things. So thanks, Xilinx, for sponsoring this stream. Speaking of sponsoring, I wanted to give a big shout out to this campaign. So one of the gentlemen who is instrumental in the Python on hardware community is Damien George, who is the founder of MicroPython. And now he is, as many open source contributors are, not getting enough to be able to survive and thrive. So please, if you want MicroPython, if you're using MicroPython in your work, if you're using CircuitPython, please, let's try and get him towards his $10,000 per month goal to be able to, for him and colleagues to be able to concentrate on his work. So if you're a regular user, please consider supporting your friendly open source community by giving them some money. So I'm happy to say that CrowdSupply is going to be a monthly contributor to this, along with Adafruit, and a big shout out to Adafruit for making us all aware of this issue in our community. So yes, please do go along and support Damien's work at MicroPython. Now, let me remove this. Oh, again, too many things to look at. And without further ado, let's bring on my fabulous guest today. Very excited to welcome Anne. Hello, Anne. Nice to see you.
Good to see you too.
Yay. Fantastic. Well, before I get started, I'd love to say to see who's with us today. We've got Haywire, who came last week as well. So hi, thanks for joining us again. And we've got the delightful Liz City DIY. Hello, we love you. Your work is fantastic. Glad you're out there in the community, and thank you for joining us today. Ready for another great teardown session. Thank you. Michael Bowles is saying aloha. iShotJR says, oops, I'm late. No, you are just on time. Just on time. Giving some shout outs for Bean Counter and the Sharpie Kibo as well. Very cool. Lots of people very excited from MicroPython and appreciated that we're sharing that fundraiser as well. So that's great. Hey, and lots of purple hearts all around. How lovely. Thank you for saying hello, everybody. Now we've seen who's with us. Anne, why don't you introduce yourself and your work?
Hi, I'm Anne Barela. I'm currently working for Adafruit Industries out of New York City, and I currently assist them on the CircuitPython team, and one of my main tasks is publishing the Python on Microcontrollers newsletter, which covers CircuitPython and MicroPython and Python on small computers like Raspberry Pi and other single board computers, all the Mango Pi and Apple Pi and Banana Pi, you know, all those. They can all take advantage of CircuitPython to build great things.
That's fantastic. And Adafruit's taken pretty much a leading role in our community in developing the CircuitPython and the community around it. I wonder if you could tell us a little bit about why Adafruit's so behind CircuitPython as opposed to, you know, when I came up in embedded, it was all about Arduino and then C++, that kind of stuff. But it seems to have changed a lot recently. And Adafruit's behind a lot of that change. So I'd really love some insight from you onto why you think that is and why it's taken off so much.
Sure. Well, Lamore Freed, Lady Ada, has been a huge supporter of Arduino since the very beginning. That was the way in which we all, of a certain age, got into microcontrollers. If you weren't doing assembly language, which if you're of another certain age, you might have. But Arduino made the learning curve flatter. I mean, you could get into it. A lot of people know the C and C++ languages, and it offered an excellent way in which to program microcontrollers that was abstracted a bit from the actual hardware. So you'll find many open source libraries from Adafruit. They manufactured a lot of different hardware for the Arduino system, but they recognized that there was still a techie level of understanding that was necessary to program. That curve was just not quite as flat as they like to see it. And they're rather keen on looking at trends on how things are going. And one trend that they were noticing was that Python was chosen by the Raspberry Pi Foundation as the programming language to program Raspberry Pi equipment. And schools in the UK, in France, in the US, and other places started deciding to teach Python as the language in which they will teach students. And it's like, okay, well, Python's becoming more prevalent. If you look at some of the polls on popular languages, Python has crept up to the top. So they looked around, and yes, somebody had created Python for microcontrollers. Damien had done that, and it's like this is the perfect foundation to get to the next level. You know, I don't know, something Arduino 2.0 or programming hardware 2.0, something if you want to use that kind of language. But they decided to kind of go all in, and and it's worked out quite well. Python on hardware has really taken off.
Enormously so. When you say that the Adafruit has gone all in, do you still? So for context here, last week I spoke with Eugene from StereoPi, which is a wonderful device, stereoscopic imaging with the Raspberry Pi. But he is saying that he maintains two code bases now, one in C++ for embedded, more corporate customers, and the Python code base, which is used overwhelmingly by hobbyists and artists and people who are new to the space, and also younger people as well. And I was wondering if what Adafruit is doing, are they planning on maintaining both? I mean, because your audience is quite hobbyist, but you do also sell quite a lot into industry as well. So I'd be curious to hear you talk about that split and what Adafruit is planning to do.
Sure. Adafruit is definitely staying in the C++ realm. There's a lot of things that you can do in C that might not be as easy in Python. Actually, some parts of CircuitPython are coded in C and bolted on.
Oh, really?
Yes.
I'd love to hear more about that. And yeah, finish your thought though. Carry on.
But if you go to the Adafruit repositories on GitHub, you will see both Adafruit's software for Arduino type product. Whenever they introduce a new product, I don't know. Okay, here we go. So we have a little display here bolted onto a Circuit Playground Bluefruit.
I'm just going to spotlight you so we can see that.
Sure.
Lovely.
And these type of display LCD displays have a driver chip, and you need to have your microcontroller talk to that driver chip to make the display. So what you'll find is that there is both Arduino code and CircuitPython code that will provide you that capability. And actually, I believe Lady Ada has stated that in a lot of products, she will go ahead and write the Arduino code first, test it out, get it all working, and then look to port the CircuitPython code. Because some of this stuff is very low level. You're talking to registers on chips and stuff. And so, she being the brilliant MIT engineer is doing all this hard work. And then there's the level of, say, you and me who are kind of used to this stuff, and we can understand kind of bolting onto it. But then you have your students, your folks learning, and they're kind of going, there's a chip on there and it somehow displays and it connects the microcontroller. If you're programming in CircuitPython, you can abstract almost all that away and say, I'm just using Python that says I'm opening this display and running with it. And then you could say, okay, well, I didn't really need Bluetooth capability here. I can go with the regular Circuit Playground Express. I can buy a bunch of these for students, say, and it's like, okay, well, I can take the code which runs on this, which is a very different microcontroller from Nordic, and I can run it on this board, which has a microcontroller from Microchip, and it's the same code. It just works. Versus if you have to go down to C or below, it's very different architectures, and you're going to find you have to do a lot of different things. But you don't have to worry about that at the Python level.
So that's really interesting.
So Adafruit is definitely staying with both, and there's no worries whatsoever. But they have put considerable resources into CircuitPython and working with MicroPython. It's a collaborative effort. There's no
absolutely
us and them, and we can talk about that more as we go along. To provide this Python in this space for people to use and create things. And I know you're a great creator. I mean, you've built some fabulous things, and that's
Less in Python. I've made a few projects in CircuitPython, but I came up in the Arduino age, so I generally write in C++ or some kind of either C++ or the Arduino version of C++. But I am finding more and more now. I am turning towards Python. It's just so easy and readable. It's in some ways it's a little bit like. Yeah, it is. If you're creating something and you're not that interested in how well it performs, in particular, if you just want it to be like, do it, fine. But if I find, well, actually, let's use this opportunity to talk a little bit about the strengths and weaknesses of Python, because it is quite a memory-hungry language, right? When you're designing the boards.
It is more. I mean, obviously, it doesn't run on your Arduino Uno level chip. CircuitPython, kind of the minimum chip is the SAMD21 series on the Circuit Playground Express. And if you give it more RAM, if you give it more flash, it likes to use it. I mean, it's not so hungry that it insists on a Raspberry Pi to run effectively. But you can do more. I like the SAMD51 chip on this Metro here. It has more of everything and is a chip. They're a little hard to get right now.
So I'm told. Is there some kind of shortage going on?
Yes, there's a chip shortage, but fortunately,
you've even got a jingle for that, which has been going right. So, for those of you who are watching this that don't know this already, so Adafruit have just started doing a stream or a little video program about the chip shortage. And they've made a jingle for it, and it is the most earwormy jingle of all of the Adafruit. I can't stop going around singing "It's a chip shortage." So, if you're interested in the chip shortage, go and check out those videos. There's some really interesting discussions on different components that aren't available, why that is, and a healthy amount of begging as well, because that's what we're resorting to at this point.
You got to do what you got to do at a certain point, and one of those segments was devoted to the microcontroller that's used on the Pi board for MicroPython. That's their kind of development board that they sell, and if they're not selling development boards, that's a revenue stream they're not getting. So we put out a plea that, hey, if they could come out with some of those chips and sell them to the MicroPython folks, then we'll have more hardware in circulation. But one chip that you can get right now, fortunately, is the Raspberry Pi RP2040. And that's probably showing up in more crowd supply projects.
It is.
People can get it. I mean,
yes, absolutely. We've got quite a few RP2040 projects in the various parts of the pipeline just because it's obtainable.
It's obtainable, and it's a great chip. Between that and the ESP32 series, which is on this,
also available.
Yes, it's available also. So you'll see a large number using that. And it's very fortunate that both of them have more RAM and more flash than the SAMD21. So you can do more, both with CircuitPython, MicroPython, Arduino, your favorite language. And it allows people that are doing development in those languages to add more features. And that's something that, again, helps the communities to say, there's this new audio. Well, okay, I'll take an example. Is MP3 playback. MP3 just came off of patent, and it's now freely available.
I did not know that. I feel like I should have known that, but that fact had escaped me. When did that happen?
Not horrendously long ago. I want to say about a year ago. But
I'll forgive myself then.
So if you want, there's code out there. There's open source code that plays MP3 files, but it generally won't. You can't do that on a Arduino Uno level. You need something with more memory and something that might be able to access a SD card or something that's storing your songs. Adafruit has taken that code and made an MP3 library. And so on many of the products that they sell, you can now play MP3 files, which is nice. And then again, the code is open source. If others want to peek under the hood and use it, that's fine too. So that's a capability we didn't have long ago that now is a part of the tool set for creative people like you to add to their projects, which is wonderful. We all like blinky lights and like the NeoPixels, here, but music too, that adds,
I know, that's mine. I'm not so much of a blinky lights person, although I do enjoy other people's blinky lights. But yeah, it's the noises, the bleeps and the bloops. That's what gets me going about electronics. Definitely.
Sure.
All right, let me just take a moment to look at some of the people who have been commenting, because lots of people have been chatting with us. So lovely, Romilly Corking has just turned up. Hello, Romilly. Now, Romilly actually was the first person to teach me a line of Python in my hackerspace in London, which I'd forgotten about until just this second. So big up, Romilly. Thank you for coming all those years ago and introducing me to Python. How funny. Now, we've also got iShotJR.com, who says, I'm literally Pythoning on Adafruit hardware as we speak. That's what we like to hear.
Bravo.
And saying, oh no, am I of a certain age? Yes, if you're a certain, I know we're accepting that. We're accepting that. If you came up on Arduino, you're now of a certain age. And then Michael saying, lol, I'm of the assembly language age and punch cards once.
Well,
see, that's pretty OG.
We might have been in the same classroom. I won't just else,
And David's iShotJR's actual name. So that's super cool, Michael Bowles. I'm learning 6502 ASM recently. Very cool. And then said, I was skeptical at first about Python, but for iterating on ideas, it is crazy fast. I had the same journey. I agree with you. And then Liz pipes up saying, yes, no compiling, which is nice. And I want to come back to that later, because actually that's one of the more exciting features of Python on hardware is this lovely REPL functionality, and I would like to talk about that in a bit. And Leon Anavi, who is an open source hardware creator with us, makes all sorts of lovely things, says, I'm also exploring CircuitPython recently because of the awesome open source KMK mechanical keyboard firmware. Lovely. What else have we got? Oh my God, we've got so many comments. You're very popular, Anne. David says Adafruit also makes a nice RP2040 feather, which is available. And we've got Liz, who shares that Qt RPi 2040 or Qt Pi ESP32S2 have been my go-tos lately. At least RP2040 is still easy to find on the market. Oh, and yes, this is a good one as well. So Leon's also pointed out that now we have ESP microcontrollers with RISC-V. Pretty excited about that. Yeah, me too. I'm very excited about all these RISC-V developments. Very cool.
Yes.
And USB-C, saying +1 for USB-C. This is the future. And Romilly remembers. I remember it well. Helen, you were a great student. Thank you so much. I enjoyed learning Python with you. Thank you, Romilly. So let's talk about the fact. Let's go back to what Liz said earlier. No compiling, which is nice. Do you want to explain what that means for those people who aren't aware of this feature of CircuitPython?
Sure. That's actually one of the main features why CircuitPython was made a part in GitHub speak. It's called forked. It was forked from MicroPython. It is still kept up with MicroPython. It's not us and them again. It's whenever MicroPython goes through a new version, eventually CircuitPython will incorporate those new features to stay up. But Adafruit really wanted that ease of use for students and newcomers, and very good. It's not their total customer base. There's a lot of people who do prototyping and other types of work who use their products, but a lot of people are learning this. So what they were looking towards is firmware in which you plug in. Somebody's mentioning RP2040 Feather. It's right there.
Yeah,
got a USB port, so I just plug it in and with my trusty cable, and it shows up as a flash drive on your computer, Windows, Mac, Linux, Chromebook too, and phone. We had a guide plugging it into your iPhone, so it should work with iPhone and Android too. You plug it in, it shows up as a flash drive. You edit your Python code in any text editor you have, from Notepad, from back in the Windows 3 days, all the way up to whatever you like to edit it in. You copy it over to the device that shows up like a flash drive, and it just runs. There's no compiling. There's no. It just happens. And if you've used Arduino and other boards, there's this step where you have to compile and check the code, and if there are errors, you have to go back and fix it. And eventually, when it's done, you can somehow load it to your board, which it's not via like copying a file. It varies from board to board how the mechanism is to download. So you can, like they said, you can iterate extremely fast. You can go and put a version of your code there. You were mentioning the REPL. REPL allows you to enter commands in Python in a command prompt method. So if you want to talk to the board, all you need is like a terminal emulator or an editor which has that capability built in, like the Moo editor. We like the Moo editor a lot.
I use that one too.
Yeah, out of the UK. And you can talk to it. You can type to it and issue commands. You can see error messages and figure out what's going on. And it's a very quick type of thing where you say, oh, I didn't do this, and you go back and edit it real quick, and you just pop it on, and it runs. Now, again, Python is an interpreted language. It will not run as fast as a compiled language. But again, the microcontrollers I was showing you all have more speed than your typical Uno level microcontroller. And it's actually pretty speedy. And if you get, RP2040 or SAMD51 or one of the nicer ESP32s, a lot of people won't notice the difference if your code is not like super critical. And actually, like say NeoPixel timing is one of those things that is critical, to talk to it in a very specific code and time frame. But that work has been done by Adafruit and others, and people doing open source. They figured all that hard stuff out, and they put a library out there that says, I just want to write, this color to this pixel, and it works. And you don't have to get down to that lower level.
Yeah. I want to pick up on something you just said that I did not know, which is you can plug this thing into your phone now. And tell me, because I know that I spoke to Scott a year ago, and he was talking about wanting to do CircuitPython on phones. Is that now? Can we do that now?
Yes.
Like what?
There were some
tweets
done by Paint Your Dragon on Twitter, and he was showing that method. You get some little foldable travel keyboard, and it plugs into, and say, an iPhone. And there was a software package, I believe, to kind of connect the two. And you need to be familiar with I don't know. I haven't done it myself. I've used Chrome, for example. But yes, it's that we're at that level where you can do that. Plus, some of the devices now, even ones on Crowd Supply, like those little terminals. If we can plug some of those into the boards, we might actually have that capability too, where you're editing things. So we're at this cusp of something that you really haven't been able to do before, and I ask you all to keep an eye out on what's going on.
There's so much development happening. I mean, who's actually on this? How many people are on the CircuitPython team? There's Katney, you, Scott. The three of you, or
Melissa, Jeff?
Oh yes, of course. So there's quite a few of you working on this.
Yeah, she's our newest member. She's now with Adafruit.
Yeah, I was so happy to see that.
Yeah, she's wonderful, and she brings.
Yeah, Liz is amazing.
Yeah.
Love, big love for you, Liz. Love your work so much. And here we are. And Liz is just here. LED animation library is fantastic in CircuitPython. It is really fantastic. Yeah.
Now, that library, Katney and Rose Hooper wrote that, and that provides, again, that level of abstraction that you just say, I want to do this. This is what my project looks like, as far as, a square or a circle or this or that. And these are the colors I want to pump out to it. And it just works. You don't have to worry about, in Arduino even, it would take forever. You would have, hundreds of lines of code, whereas that library squishes it all down to, 20.
Yeah, fantastic. Oh, so I've got a few comments here. So we've got Dasha Poo. Hello, thank you for joining us again. And says, I really like the S2 Mini because it's pin compatible with the D1 Mini and all those shields. Yes, absolutely. And David said, challenge accepted. I am going to write some CircuitPython on Windows 3 this weekend. Of course you are. Of course you are. Brent's popped in to say hello.
Hey, Brent. The USB support on Windows 3 is, so I would go up. Windows XP does well on, so I'd stick to that level.
Very funny. All right. We've also got David saying that he uses the keyboard FeatherWing as a little Python cyberdeck. It can edit files, REPL, etc. David, can you check a link to that? Or if there's a link to a tutorial or more information on being able to do that, I'll share that on the stream, because I think that's really interesting, an interesting thing. And some love back from Liz. How lovely. Okay, I did want to also say that one of the things that I love using the REPL for is calibrating and kind of feeling my way around how different sensors work and how they're and how they're interacting with different things. Because you can just be like, oh, that's not quite right, or oh, this is not the right angle, or you can just iterate so quickly and test your assumptions so quickly that I find it like extremely useful for rapid prototyping. Yes, it's really fantastic.
Well, you can also query what methods are available in certain functions.
Yes.
And you can say, okay, well, is the string conversion available for that? And you just type one command to say what does the method have with it, and it's like, boom, it's like, yes, it's there. Okay, I can just use it, rather than get online and start digging into the documentation. So again, it's that quickness. Do what you want to do, and not have to go down a rabbit hole in documentation. Yeah,
absolutely. So I would like to ask you a question about your own personal experience as an engineer, and where did you go to college to do an engineering degree? Are you self-taught later? Did you start in embedded or online? And I'd also be like, as you tell the story, I'd be really interested to hear how you feel like the languages and the communities have changed over the course of your career.
Sure.
In this, if that's not too big a question.
No,
I'm very curious. I actually don't know any of this, so I'm very curious.
I can't put it into a sentence, but I was fortunate that my high school had electronics class, so I got a good basis for learning electronics, and also there was a computer class where I learned Fortran and COBOL. I won't tell you what kind of machine, but it had like little pieces of paper with little dots taken out of it. And then that's what I wanted to do. I wanted to be an electrical engineer. So I figured out the best path for me, and that was starting off at Whitman College in Washington State, the opposite corner from where you and got a decent liberal arts education, and through a program they had with the California Institute of Technology, I transferred and did my electrical engineering courses and programming, and that's where I learned C and how to lay out chips with software and all kinds of fun stuff, and watch one of my classmates use their microprocessor skills that we were all learning to hack the scoreboard at the Rose Bowl the year I graduated. So there we were learning on microprocessors, and it's very similar to microcontrollers, except you have to have external RAM, external ROM. It wasn't all packaged together back then. So we were programming 6502. Somebody mentioned that they were into that, and several other different things. The 68,000 had just came out. I did a project in the 6809. It was all good fun, using different environments to build hardware that did things that people wanted to see. So I took that, and I was actually working that summer with the Jet Propulsion Laboratory for NASA, which is with Caltech. And we were making a synthetic aperture radar to penetrate through foliage and sand and stuff to see what was below. And that was eventually modified to be used on the space shuttle. So I found lots of very cool stuff.
That's extremely cool. Extremely cool.
I could have stayed. They offered me a job, but I wanted to go to the Pacific Northwest. And you know how beautiful it is up there.
It is, yes.
I accepted a job at Boeing and was doing that for a bit. But it wasn't my thing. So there was an ad in the newspaper that said, see interesting people and places and join the U.S. Department of State. So I went and did that and became an engineer for them, and an engineer and a diplomat. So
how many people can say that? How many people can say that, Anne? Not many.
There are only
an engineer and a diplomat.
There are only about 100, 200 people for the United States that are able to do that. But it provided me with a great opportunity to travel. I lived in 5 different countries. I traveled to many, many more. And it was just a lovely career, seeing places, meeting people, and doing great things to protect people. It was security engineering. So I loved it. But I knew I was eventually going to retire. And it's like, what are you going to do? Sit on the couch? No. Well, I said I really liked doing all that microprocessor coding. It's like, what's happening these days? And I, like everybody else, I got into Arduino. And it was Tom Igoe's book, Making Things Talk, which just like showing how you could connect microcontrollers and various peripherals and Bluetooth and stuff, and making these things that actually excite people. So I started doing that. And, I found that back then things were kind of expensive. An Arduino Uno was like $35. But Adafruit started making a small board called the Trinket, which was only $10 at the time. It's less now. And it's like, okay, what can I do with this? And it's like, it's different enough, the AT Tiny 85, that some of the Uno things didn't work. So I had to Google and tinker and start making things happen. And Adafruit started seeing what I was doing. And they said, hey, you're doing stuff. Would you write up some of your work for Adafruit on their learning system? I said, sure, and that gave me an opportunity to dig deeper, and they connected me with the Make community, and they asked me to write a book on the subject. So I wrote my first book on the getting started with the Trinket. And so
that's so good.
Yeah, and in retiring and actually retiring rather than thinking of retiring, I was invited by Adafruit to come up to New York City and kind of see things, and we were having dinner, and I said, would you like to do that full time? It's like, sure, that sounds real good. I can do what I like full time, so I did that. And about the same time, they came out with the Circuit Playground Express, and they said, Make said, we'd like a book on that one too, which has proven to be a lot more popular board for education and everything. And so, voila, I can't.
Like this?
Yeah, there you go. Thank you.
There you go. Look, Getting Started with Adafruit, Circuit Playground Express by Anne Barela. So you're an author, an engineer, and a diplomat. Fantastic. I did also, while this is up, wanted to show this. This is the QWERTY keyboard FeatherWing that David was talking about earlier, making a nice little thing.
I believe there are new, other people are making very similar things, and using the newer BlackBerry keyboard, the one with the little mouse kind of nubbin at the top. It's brilliant.
Yeah.
And I've got a keyboard, FeatherWing, and that's what I've wanted to do, is make a little cyberdeck out of it. So
have you seen Arturo? Arturo, who does Solder Party. He's done
that's
some.
That's who I bought it from. He's
oh, you did. There we are then.
Yeah.
He's so lovely. Yeah.
So,
really nice. In fact, I just got a package from him today, so I'm excited to do that after the stream. I know, so very exciting. I wanted to take a minute to have a look at some of the comments, because we've had so many of them in between this. So David says, heck yeah, 68K, when is Anne's autobiography coming out?
Well, there's still a couple chapters left,
Good to hear. We got Salman saying good vibes, and Anne has such a cool and varied career in engineering. I fully agree. David's saying the title of this thing should be an engineer and a diplomat. I fully agree. And also they agreed with your shout out for the book that you really loved, that blew your mind. Then we've got also Brent Rubel saying diplomatic engineering. Yes. And with that comment, Brent, you have won this week's mystery hardware box. So let's have a little look inside and see what you've won. All you have to do is send me your name and address on Twitter. You can DM either me, Helen Leigh, or Crowd Supply, which is crowd_supply, and just drop us your details. And inside this week's mystery hardware box, we've got all sorts of goodies. First of all, we've got some very fetching Xilinx socks from our sponsor. Who doesn't love socks? We have got a Circuit Scribe kit, which is it's a little conductive ink pen that you can use to make your own curations. You've got some Crowd Supply swag and stickers. This is a little laser cut thing, and we've got a Circuit Playground Express to give away in this box, which we love, Circuit Playground Express, and also an Adafruit clue as well. So you've got all sorts of goodies coming your way. Congratulations for winning this week's mystery hardware box, Brent, and please do drop me your details. Okay, put that away and continue. What else have we got to say? So Michael Bowles has said, I've got 3 years of high school electronics. It's a great place to start. My school didn't offer that. My high school electronics education was all learned in hackerspaces. No electronics where I went, but it sounds amazing. Still working with vacuum tubes. Very cool. Very cool. Yes, and lots of other calls for the autobiography. How lovely. Then Brent, here we are. Didn't know there was a mystery box. Came to support Anne and hang out before the long weekend. Well, isn't that lovely? Congratulations. All right, lovely. Very lively chat today. You're very popular, Anne. We like to see that. Fantastic. Is there anything else you'd like to share about that particular thing, or about your experiences over your career and how they've how languages have changed, or the communities? Well, actually, I do have a question which is linked to this. So one of the things that I hear a lot about the Python on hardware community in general, and the CircuitPython community specifically, is that it's very inclusive and it's a very friendly, warm, and welcoming place. And I wonder how you felt as you've been part of the different communities of the different programming languages and hardware communities throughout the course of your career, and how you feel that the CircuitPython is different or not different, or sure. Be interested to hear about that.
Well, again, if you go back to some of the older experiences, say in the Arduino era, things might be kind of spotty. There was AVR Freaks, which was a kind of a AVR specific, but they were they wanted you to know your stuff before you came in and asked questions, and that was a high barrier. There just wasn't as many resources. I mean, and people were looking for those because you have Facebook and Twitter and everything, and people said, well, where are the social areas for people that are interested in Python or Python on hardware or something like that? They didn't necessarily exist before, but people were eager for that. So Adafruit, again, has been a company that has embraced social media. They're on all of the major platforms. They've tried out several things. They were doing Google Hangouts for their shows for a while before that wrapped up. They've been innovating, and even on TikTok now. I mean, that's kind of on the rise.
Oh, really? I've not done that yet. I think I'm too old.
I mean, I'm sorry, but one, they built their forums, which you can ask all this information. I'm active in the Adafruit and CircuitPython subreddits, for example. But obviously, you've got my handle right there. I've been on Twitter for quite a while. I respond to a lot of things in the community on Twitter. I think that's one of the first places I met you. You find makers that are doing similar things to what you're doing, or I find they're doing just cool stuff that I like, and so the keyboard FeatherWing, for example, Arturo, I found what he was doing on Twitter, and it's like, wow, I like this. I'm going to follow you and see all of these projects going on. And so you build up this list of people that are doing what you like to do. Now, you can get a hold of individuals on Twitter, and you can do like the forums and ask kind of questions, but it still wasn't quite frictionless, I'll say. Then came along Discord, and Discord provides a really nice capability. So Adafruit set up a Discord server. It's very popular. It's got over 34.
So popular. Yeah.
But it provides a lot of capability now. They've been building their capabilities too. So the Adafruit community on Discord is where you can get like real-time interact with people who are doing cool things, interact with some of the Adafruit folks. We have a weekly CircuitPython chat on Mondays at 2 p.m. Eastern. That'd be like 11 Pacific. and people from all around the world jump in on that, and you've got the engineers right there. I mean, Scott Shawcroft, the lead programmer, is there, just back from paternity baby leave.
Oh, yes, of course.
Yes,
Of course he is.
new baby boys, and you can see what is going on. What are the areas that Adafruit and the engineers are really looking towards? Thanks, that's great. And you can ask your questions. I've been really having problems. I've been finding this bug that's been really bothering me, and you can get real-time help. And so, again, Discord isn't the be-all end-all for everybody. For people of a certain age, they may say that's for the kids. Who knows? But there are multiple places in which you can get help. And one of the CircuitPython mottos, it's done on the Adafruit shows, is code plus community, because you need to be inclusive and build a community in order to have a vibrant code base and set of users. If you go on GitHub, you can see untold number of projects, and they might be very nice projects, but if somebody is very kind of holding it close to the vest and not kind of saying, hey, kick the tires, try it out, I'll incorporate PRs and issues and stuff to make it more of an interactive thing, it's not maybe going to do as well, if at all. So Adafruit really welcomes that. And again, that synergy we were talking about between MicroPython and CircuitPython, there are things in which Adafruit and the CircuitPython community contribute back to the MicroPython communities, and again, that wraps into CircuitPython, so it's a speed. Now, I've got the poster for CircuitPython 7 right there, and it has Blinka, the purple snake, for you, and the Python snake is red. I don't believe they have a name or anything, but it's to show that the latest version, we are together, and this community, this sharing, trying to ensure the MicroPython community is just as vibrant. They've got their own social media. We participate in some of that too, but we want to have their GitHub, their ability to develop and innovate on MicroPython to continue. And thank you to everybody who's contributed to the GitHub sponsorship for MicroPython. Adafruit contributes for CircuitPython. There's no crowdfunding for it, but they encourage you to help MicroPython, and that helps everybody.
We'll give another shout out there. Actually, this is a good time. There's a couple of other Python things that I thought people would be interested to hear about. So you talked a little bit earlier about doing circuit design, but have you played with Python circuit design? So this is something that actually Bunny Huang told me about, I think. And Migen is something that a lot of people are playing with at the moment. Lots of people are excited about it. It's a way of doing hardware design using Python. I haven't personally used it yet, but I've heard a lot of people saying a lot of interesting things about that. So I just wanted to flag up that exists. Really interesting thing. There's also this other little thing which is actually by Xilinx, which is another open source project called Pink. So this is really interesting way of dealing with some of their stuff. So that's pretty cool. I did also want to say that this is actually one of my old articles. It's that I wrote for Make, and it was all about Python on hardware. So if those of you this is actually a decent summary of the differences, and with an introduction to how to start using it as well. So if those of you aren't familiar with Python and are just here to check it out, this might actually be an interesting beginner article for you. Mm-hmm. I did also want to give a quick little shout out to the Adafruit GitHub, which is where we can find all of the repos and all of the information that we've been talking about. And then also another shout out, just because why not? Another shout out to this GitHub sponsors project that we're trying to get up to the goal there for the creator of MicroPython. Let's show him some open source love from our community. Look at that, 121 sponsors. And straight after the stream, CircuitPython is going to be the newest one. So I was going to do it before the stream, but my two-factor authentication thwarted me. So I'll do that afterwards. So yeah, big shout out to that. Lovely. All right. Had you seen Migen? I don't know how you pronounce it, but have you seen that?
I haven't seen that. Again, I kind of alluded to in university, they were just doing some of the very early layout of VLSI with programming, but it was all proprietary, and I love the idea that you can use Python and leverage a language in which you already know to do that kind of work, and Pink too. That's lovely. I have to give AMD some credit. I run a Threadripper computer here, and it's brilliant. I can just dice through video and everything, and it works beautifully. So I'm a big AMD fan, and them being with Xilinx is brilliant. I welcome.
I think so too. Yeah, is it Xilinx-AMD now, or yeah, I think it's Xilinx-AMD for the time being, anyway. But yeah, that was an interesting acquisition. Yeah, very cool, very cool. Well, somewhat improbably, we are now at 56 minutes in. We've only got 4 minutes left of the stream. Is there anything you would like to share with the audience? So if there's anything that you want to promote or talk about in terms of things that you're really excited about, shout out to some people who are doing really interesting things with Python that these people might enjoy. Now is your time. And for those of you watching at home, now is the time. If you have any final questions to ask Anne, please do shout out and let us know. It's been a really, really exciting stream, and we've talked about a lot. We've talked about the differences between MicroPython and CircuitPython, about the evolution of this embedded space. And I'm curious to hear about where you think this is going next as well. Are we just seeing, where is CircuitPython going to be developing, and what are the new big things that we're going to be seeing on the horizon here for this community?
CircuitPython and MicroPython are both looking at other hardware architectures, the IMX series and several others. ST was coming out with bigger and faster chips, which that's kind of the MicroPython bread and butter. But the chip shortage has kind of impacted that to a great degree. If we can't get the chips to come up with new variants and utilize all this new hardware, it's very hard to bring them to you all. But leveraging Moore's law, that there are bigger and faster chips that cost less, is a win-win for everybody. And I can't stress enough the ability to allow people who have ideas, project ideas, creative ideas, art projects, whatever they have. It starts off from the Arduino era, but it goes straight to now, that you can conceptualize what you want to do, and then look at the tools available, hardware and software, and say that something like CircuitPython, you can bring that to fruition a lot easier, cheaper, faster than you might have been able to do it 2, 3, 4 years ago.
Yeah, I absolutely agree. It's been a huge move forward in the community, for sure. And I think it's brought a lot of software programmers into hardware, actually. There's lots of people who came from Python to hardware, which I think is very interesting.
I do kind of tease the people in the Python subreddit to maybe come over to the hardware side, check it out. I can show them neat little things. Like I programmed this display to come up with the next SpaceX launch, and it uses Wi-Fi from the ESP32.
The mag tag. We love a mag tag.
Yeah, and you can say, okay, well, everybody likes space launches. I mean, I live very near Kennedy Space Center. It's like, wow, you can do that with Python? It said, yes, with one little e-paper display, and you put some Python on it, and it pulls stuff from the internet and just works. And you can entice some of those other Python people to say, hey, I want to do that too.
So cool. Okay, we've got one final question and then one comment. I've got David saying, what is your next book going to be? That's a very good question. Another CircuitPython, or is it finally going to be your autobiography?
No, it is not. I've got a little bit left to do. I've got a brand new base I'm going to be building starting tomorrow. So I don't have anything in the pipeline. I mean, Adafruit's always coming out with some great hardware. People have been clamoring for a CircuitPython book, and a few people I hear might be working on one. But it's a very tough thing. It's not quite as the Make series. It's a getting started. Whereas if you were to say, I'm going to write a book on CircuitPython or MicroPython or both or something, it's a very broad topic, and it take a lot of work. And if
writing a book is a lot of work.
Oh gosh, yes.
We both know this. We know this.
We do, and
way too much work.
And there's not this Stephen King revenue that comes in afterwards. Yes. So you and I, we enjoy our residual checks. We can buy a coffee at Starbucks, and that's about it.
That's the level. I'm like, oh, let's go out for a drink on my 6 months of royalties, but not a cocktail, maybe like a glass of wine.
There you go. It's very true that you will not get rich writing books about electronics, but
no,
I'm glad that people like you and many others that I'm familiar with they put that effort in. Liz wrote a great book on the Tinker board that people do that. Now, I've not been approached to make a book. I've been rather busy, again, moving and setting up a new makerspace to be as nice as the one you have behind you.
I've just finished mine.
It's beautiful.
I know, I'm very happy.
Yes, so I want to do the same thing. So that's where I'm putting my effort right now. There may be a book eventually, but you all are going to have to wait. And, leave me a comment on Twitter if there's something you really want to see. We could pitch it to the publishers, but we try to have a life beyond electronics every now and then too. Yeah,
we try to. It doesn't always succeed, but we try to. I have, firstly, Michael said thank you for all of the things that you've shared, which I echo. Well, also, Jorvon Moss just popped up as well, saying, I can't imagine writing a book. Well, one day maybe, Jorvon, but you're also very good at video, so
yes,
just that I'm not that great at. So, but nice to see you as well. Thanks for dropping in. And I wanted to end with this really positive comment from Romilly, who is saying, one exciting thing to look forward to is that MicroPython should finally get into space this year, thanks to Damien's work for the ESA. Very exciting to hear that kind of thing. We've it was all very exciting. Actually the Crowd Supply logo is currently floating around space on a border, because Oregon just launched their first satellite, and we're like one of the supporters on the thing. So we've got it floating around space right now, which pleased me a lot. By the way, before we sign off, I love your circuit board dress. I love it.
Thank you.
I love it so much. It's so cool.
I want to point out the Python in Space sticker too.
Yay! Oh my God!
Python in Space. So I've got all this NASA swag on my laptop.
I love it. I love it.
There is CircuitPython Space. We love MicroPython in Space. That people can get that kind of hardware up there and not have to write at the lower level, space is the place. And I live near one of the biggest spaceports in the world and get to see all the space.
So exciting. How fun. Well, we've gone over, we're 5 minutes over, Anne. So it is now time to say goodbye to all of our lovely viewers and also yourself. Thank you so much for this session. It was packed with so much good information and so many inspiring tips. And I also really loved hearing about your life in engineering and as an engineering diplomat/author, you know, pretty big flex there. So thanks to everybody who joined us, including Liz and Jovan. Trevor Flowers turned up. Hi, nice to see you. Romilly says, thanks, super session. And David also, awesome session. Thank you for joining us. I am going to be in the UK next week for the EMF camp, so there will be no live stream, which I'm very excited about, unless I manage to get my act together and stream from a field, but I don't think I'm going to be able to do that. So next week I'll be in EMF camp, and we'll be back in a couple of weeks. I'll send out the details. We're still firming out our next few guests, but we've got some really exciting ones coming up in the pipeline, definitely, but not ready to announce yet. So thank you, everybody, for joining us. I will see you again soon. So many thanks to you, Anne. Bye now. Bye.